Pre-AP Unit 7, Graphing Quadratics Retest Review. Just a quick reminder, you definitely want to make sure that you can do all of these problems by yourself before actually taking your retake. So even though you're going to watch me do them right now, you're going to feel great about it. Make sure you actually take the time to do the problems by yourself before retesting because the problems are so similar. All right, domain. Here we go. We're looking at the graph to answer this first question, domain and range here. Because my graph is going right and left forever, right, every single part of the graph will be covered. And so my domain here is all real numbers. The range, however, does not have up and down forever, right? It starts here and then goes up. So my range is not all real numbers. My range, again, starts here, where the y value is -4, and then we go up. So all the y's are -4 or above. So we say all the y's are greater than or equal to -4. And that's it for number one. What's number two? What is the vertex of the graph? And then we've got f of x equals 2, blah, blah, blah. If you get an equation and you're asked for the vertex, please just graph it at least just to see if it gives you an easy vertex. So we're going to go ahead and we're going to go to y equals, and we're going to type this equation in there. Clear out anything that's already there like I have to do. Here we go, 2 parentheses, x minus 5. Don't forget the little squared symbol on the end there or you'll be wrong. Then we got a plus 3, so let's take a look. All right, so we can see that my vertex is right here. If you don't know that that's the vertex, you're in trouble. You need to go to tutoring in addition to this video, probably. So we got this vertex right here. We go over 1, 2, 3, 4, 5, and up 1, 2, 3. We can always double check this looking at our table, right? That was the lowest point on the graph. We thought we went over 5 and up 3. And so we can just kind of check it here, right? Yep, 3 is the lowest point out of my y values, right? This is the lowest point on my parabola. One more time, check the table. Yep, that's the lowest one. That is my vertex. So my point right there was over 5 and up 3. And that is my answer. Question number 3, what is the axis of symmetry of the graph? The graph is a good way to answer this question too, but I just want to make sure you guys don't forget we have a formula because sometimes the formula is definitely necessary. Sometimes the graph kind of fails us for axis of symmetry. So let's remind ourselves of the formula. We got x equals -b over 2a. This requires us to know the number with x squared is a, the number with x is b, and the number on the end is c. So let's plug these numbers in. We got -b over 2a. All right, well, b is -3, so that goes up top, and a is 1, which you can see I already wrote in. And now we just got to simplify. So we got x equals +3, right? Negative makes a +3 over 2, and that's my answer. If you want to write it as a decimal, 1.5, that is also fine. Again, I said this earlier, but if you do want to check in your calculator just to kind of make sure that this is getting you a reasonable answer, type it in. We got x squared minus 3x plus 9. And take a look at this graph. Okay, we can kind of see that this is where the axis of symmetry would be. And can you tell that it's not right at 1 and it's not right at 2? It's between 1 and 2, which is great because the answer we got was 1.5. Okay, so I just quickly checked my answer. Problem number 4. What are the x-intercepts of the graph? Hopefully you know what x-intercepts mean, right? We've been doing y-intercepts for a long time. X-intercepts is real similar. Let's go ahead and let's type these in. We got -x squared minus 5x plus 14. All right, here we go. Let's graph this thing. All right, we can see here's an x-intercept and here's another x-intercept. You know what? I'm going to draw a quick little sketch here just to kind of help me out. Got 2 zeros, 2 x-intercepts, one here, one here. All right, this one is 2, it looks like. This one is at -1, 2, 3, 4, 5, 6, 7. This one's at -7. And let's see here. We can always check the table just to make sure. So I got 2, 0, perfect. Let's look at -7, make sure I got -7, 0. Yep, there we go. So I double checked. So x equals 2 and x equals -7. And now I am confident I found the x-intercepts. Okay, problem number 5. Find the vertex of another equation. All right, well, we already did one like this, so let's put this in y equals. We got 2x squared minus 2x minus 1. Let's take a look at the graph. All right, here's my vertex right here. Let's see, is this point good? It is not. Look at this, you guys. How far do I go over? It looks like I go over 1/2 and down like 1.5. So it's decimals. All right, if we're going to do this then, we need to make sure that we use our axis of symmetry formula. And this is because, remember, your vertex, sorry about that, your vertex is always the axis of symmetry. So I'm going to put AOS, right? That's the x coordinate, the axis of symmetry. And then the y is you get it by plugging in the axis of symmetry. So that's what we're going to have to do here. So let's go ahead and let's find the axis of symmetry, because that will be finding the x coordinate of the vertex. All right, so same formula we used previously. I got negative b, which is -2, over 2 times a, which is 2. So we got a +2 over 4, which means that we were kind of correct if you guessed x equals 1/2, or 0.5. All right, actually I probably shouldn't circle that yet. So my vertex is 1/2 something, right? I got to plug it in. So I'm going to go over here, plug in for both of these x's, and I'm just going to do this in my calculator, and I encourage you to do the same thing so you don't mess it up. That sounded terrible. Just so you can be confident in your answer. All right, so we're going to go ahead. We got 2x squared, so 2, and I think x is 1/2. I'm going to use 0.5 squared minus 2x. Again, x is 0.5, and then minus 1. And I get -1.5. So -1.5. All right, there's my vertex. And that is definitely what it looked like in the graph, but I would really encourage y'all to actually go ahead and plug things in just in case you get a weird decimal like a 0.3. Do you know what I mean? Plug it in just to be sure. Okay, question 6. Write a new function in vertex form. So let's, before we go any further, let's write down vertex form. This is on your formula card, so you don't have to memorize it. We have y equals a x minus h squared plus k. All right, if the parent function y equals x squared is shifted 4 units down, okay, that's a k change, and 2 units to the right, that's an h change. Okay, so I guess we're not really worried about a. So we got y equals x minus something squared plus something. Well, the k change is really simple. 4 units down is just -4. So you know what, instead of putting plus -4, let's just put -4 on the end. Now shifted 2 units to the right would be a +4 for h. But we don't need to put that plus there, so it means it looks like -4. Remember, the sign here and this change always appear opposite. Now, I would not turn this in. I would not submit this answer. Oh, why did I write 4? It's supposed to be 2 units to the right. Sorry. I would not turn this in until I double-checked my answer. So graph this equation that you just wrote down. Make sure it's doing what it says it needs to do. So we got x minus 2 squared minus 4. Okay, remember, it needs to be 4 units down and 2 units to the right. Sorry, ignore the bell. From the parent function. Actually, you know what? Let's just graph it. So remember, the parent function is right here through the 0, 0. So did I go 4 units down? Yes. Did I go 2 units right? Yes. All right, so always double check your answer with your calculator. All right, 7, 8, and 9 are super simple, you guys. Make sure that you get these ones right. Here we go. Question number 7, 8, and 9 are using this graph. This graph is talking about Jane. She's the star shooter on the basketball team. The equation is given, but it also graphs it for you, which is kind of nice. It says this is the path the ball makes or follows when it leaves her hands. Let's look at the first question. For how long, so you know your answer is going to be in seconds, for how long is the ball at least 19 feet in the air? Well, 19 feet in the air happens here and here. But this at least part means we're talking about all the time between them, right? It's at least 19 feet for all that time. So how much time is passing? We got counting by ones, so that's nice for us. We got 1 second, 2 seconds. All right, a lot of kids, the mistake that gets made here is they'll say 1 second, 2 seconds, 3 seconds. No, 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 that's wrong. You're counting, you start here, so 1 second, 2 seconds. Question number 8, when is the ball at its highest point? Well, I know we can all see the highest point happened here. Okay, 24 feet in the air, but this question said when, so that's talking about this time, right? At 2 seconds. And then finally, what is the maximum height the ball reaches? We already kind of did that, 24 feet. So the first question, you're saying, okay, how long is it above a certain height? The next two questions are both talking about the vertex. Just one is the x value, one's the y value. Question 10, last one, here we go. For which of the following tables is the parent function y equals x squared? So really this is saying which table is quadratic, right? Because if it's a parent function of x squared, it's got to be quadratic. Remember, what we do to look at this is we look at the changes in y. The changes in x are all going up by 1, which means we can kind of ignore them. Let's see here. To get from 13 to 5, I subtract 8. From 5 to 1, I subtract 4. From 1 to 1, I don't do anything. And from 1 to 5, I add 4. Now, obviously, since these are matching, this is not linear. But we still don't know if it's quadratic. To see if it's quadratic, we have to now compare these numbers. How do I get from -8 to -4? Well, I add 4. -4 to 0, I add 4. 0 to 4, I add 4. Okay, this right here, these second differences matching, this is what tells us that this is, in fact, quadratic. So we can choose A. Just to give you a counter example, you guys, take a look at this next one. Again, all my x's are going up by 1, so I'm going to ignore them. And I'm going to look at my y's. Looks like I'm adding 3, I'm adding 3, I'm adding 3, I'm adding 3. So this means it is linear. So obviously it's not quadratic. Okay, question C. Again, look, up by 1s for my x's, so don't worry about those. My y's, let's see, I'm adding 6, and I'm adding 6, and I'm adding 6, and I'm adding 6. So this is also linear. And this last one here, let's see, it looks like I'm adding 4. Oof, now what am I doing? I'm taking away 20. Is that right? Adding 4, taking away 20. Then I'm taking away 4, and then I'm adding 12. Okay, so it's not linear. And if you wanted to check for quadratic, you would then compare these numbers. Okay, to get from 4 to -20, I have to subtract 24. To get from -20 to 4, I have to subtract, no, I have to add 16. Okay, since these numbers are not matching, I already know it's not quadratic, and I'm not going to go any further. All right, so essentially, y'all, you're looking for where second differences match. Just really quickly, something else to show you guys is if you put these tables in stat edit, right, like I already put this first table in stat edit, and if you choose quadratic regression, so stat calc, option 5, I do get an equation, and I do see the r value is 1, right? A is not 0, right? So I got 2x squared minus 2x plus 1, so this is a quadratic equation. Comparatively, if you had put in, let's do option C, just because my x's are the same. So I'm going to type in -15, and let's see, -9, -3, and 3, and 9. If I do stat edit again and choose option 5, right, quadratics, because it's a quadratics test, I get an r value of 1, but look at A, right? A is 0. If I was actually going to write this equation out, I would write y equals 0x squared plus 6x minus 3. This is not something we'd write, so we'd end up writing 6x minus 3. Y'all, that's linear. If you don't have x squared, it's not quadratic. So I've given you a couple of different ways you can figure out problem number 10. You can do it by hand like I showed you, or you can check the r values in your calculator. Remember, if you're going to do that, you have to turn on your diagnostics, which you should know how to do, but in case you don't know, it's second 0, right? Second 0, go to your catalog, scroll down to diagnostics on and press enter twice. All right, make sure you know how to do these problems by yourself, like I said. Hopefully you do, and you will do wonderful on your retest. Good luck.